Hello, I'm audible.
Yes, sir,
Yes,
you're
sir, you're
audible.
audible.
Okay. Uh, so hi, Desh.
Yeah, I'm
Yeah.
here.
Okay. So shall we start?
Yeah, please.
So this will be an orientation session for about the experiments. So we'll describe about the experiments and we'll also tell you how to do it. So you might have got the mails and which has in Google Drive, you can see there are like 4 experiments using cell phone and Wi-Fi hotspot you can perform. And there are other experiments which is based on the GMRT data and the UT radio telescope data. So where you can analyze the data reduction, you can do that. So those experiments will be conducted by Desh, Professor Avinash Deshpande, Ashish, and myself. So if you need any help, so you can contact us at any time. So you can mail us or you can tell us. So if you find any difficulty. So have you got the link and have you gone through the folders? I just want to know.
Yes, sir.
Yes.
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay, so you can see there. Just a second. So yeah, in the experiment folder, you can see there are 4 experiments. One is the back reflector, and the second experiment is the corner reflector, and the third experiment is power versus distance, which is 1 by r square, and fourth experiment is reflecting interferometer. So there are 4 experiments which you can do using cell phones and the laptop. Okay, and cell phone can be your like the transmitter. So basically in this experiment you need 2 devices. One is the transmitter and the second is the receiver. So the transmitter can be your cell phone, any smartphone, so which enable the hotspot. So you can transmit the Wi-Fi, like you can switch on the Wi-Fi, and you can receive uh, the signal or the data, so either using cell phone or either using laptop. So both can be, for some experiment you can use cell phone, and for some experiment you can use laptops. Okay, it can be operated on any platform, so whether it may be on Windows, Linux, or Mac. So anything would be fine. So Ashish will tell you how to install those software on different like platforms. So there are different softwares for different platforms, slightly different, but the principle will be same, and you can receive the data. So that can be done here. So Desh, you want to say something?
Yeah, I think for purposes of you know really capturing some data and to be able to analyze that later, uh, the recommendation would be that you use a laptop as a receiver. Uh, that might make your later
Easier.
steps easier. And
So they can record it and they can store it and later they can analyze. So that is an advantage if they use laptop. Otherwise, even at some cases, even if you don't have laptop, the cell phone, you can take manual reading and later you can like analyze the data. So that can also be done at the
might have
worst
to
case.
tabulate it yourself if you use a cell phone as a receiver.
Pradesh, you're saying something?
Yeah, yeah. I said it already. I said you know with the mobile phone as a receiver, they might have to manually note the values, right, and tabulate them.
Yeah.
Whereas there might be more convenient softwares on the laptop that might allow ready tabulation and even display or analysis, some analysis steps might be possible right there. So the recommendation is that they use laptop as a receiver.
Yeah. Yeah,
All right.
if we have a laptop, then we have a lot of advantage over the cell phone. So that's clear. So yeah, basically, so you can see if you open those folders. So we need Wireshark, so which is available for like other platforms, but it mostly used for those who are using Mac, so they can use Wireshark, and so those who are using Windows, so they can use this VS Tumbler. So and if you're using cell phones, so they can use Wi-Fi analyzer. Okay, and even they can install Wireshark on Windows also. So some people may find like little difficulty like installing in it and using it. So at that time, we can assist you. So and then after the installations, so then we can like perform our experiments. So the first experiment will be like simply power versus distance. So we know that the power will start decreasing. So once we go away from the source, so that is 1/r². So that we can verify here. So basically you need an open space or like in a room. So the result won't be uh, that result won't be that accurate. But if you have an open field, so where there are like less reflections from the other side, where they have like less wall and other construction or the machines, so you can get the appropriate results. So what we can do, so we can switch on our cell phone and hotspot, and we can keep at some time, and we'll leave it there for a while, so maybe say 1 or 2 minutes to settle down the power, and then so we can turn off our data. So we can keep it on aeroplane mode, so that it's not communicating with the local connecting area or anything. So what it will do, it will not transfer any data. So purely it will be the connectivity is stable at that time. So if you want a stable connectivity, then you have to keep your cell phone on a aeroplane mode. So then you connect to your another cell phones or on a laptop, and you can see. So you're getting some power, which is emitting from the transmitter, and you can see at the receiver end. So then you can change the distance between the transmitter and the receiver. So you can keep your transmitter at a like center point, and you can move slowly a little bit away from the transmitter. So maybe you can go like zero point 0.1 meter, or maybe like 0.25 meter. So step by step you can go, and you can record the power which is in dB. Okay, and then you can plot it. So this is a simple experiment, but we can see how it is how the power is like decreasing. So when you increase the distance, so that is a basic experiment we can do here. So that is our first experiment what we will perform tomorrow. So after installing all the softwares, and after like setting up our setup. So, and the second experiment will be like back reflector. So basically you need a reflector, which can be anything, a metal plate. If you don't have metal plate, you might have like cardboard, and you might have like the aluminum foil at your home. So simply what we can say, so take a cardboard or take a notebook, and like paste your aluminum foil on it, so which is like uniformly pasted on the cardboard or the notebook. So you can place that cardboard like just next to your transmitter, but the distance need to be lambda by 4. So generally the cell phones like in the Wi-Fi systems, they are operating at 2.4 gigahertz, which corresponds to almost like around 12 centimeter, 12.5 centimeter. So you can divide it by into 4 parts, and like you can keep that distance, and you can keep your transmitter at lambda by 4 distance. so which is coming almost like 3.3 and 3.5 centimeter. So you can see there is change in the power. So the receiving power is like slightly increased. So that you can verify here. So basically, when you any reflector, so that will reflect you the power on the backside. So if you keep a transmitter, so that is our second experiment, and the third experiment will be a corner reflector. So corner reflector is another kind of antenna. So we can see how it is working and how it is operating. So the procedure is written in the manuals. And the fourth experiment is the reflecting interferometer. So that will be explained soon. So that will be explained by Ashish. Hello.
Yeah, Jamir, we can hear you. No
Yeah.
problem. Do you have any pictures you want to share with them?
Yeah, right. Any
Yeah,
document?
so sure. Just a minute. I will
Because
share.
that'll bring it more alive. And they're also inquiring in the chat about available for Linux, which I suppose Ashish can address later.
Yeah. So I don't know whether Ashish is here because,
Yeah, I'm here. I'm here.
yeah. So I guess my screen is visible to everyone.
Yes, sir.
Yes.
It's visible.
Yeah. So these are the manuals for the experiments you can see. So here is the transmitter, and you can place a reflector plate here, like maybe which is made by aluminum foil or any metal plate. So, but basically it need to be very flat so that we get proper wavefront and waves. So, and the third experiment, which is about the corner reflector. So this is like a homemade corner reflecting antenna. So like we can take three metal plates or either three cardboard, which is like cut by 12 centimeter by 12 centimeter, and we can place it at 90-degree or orthogonal to each
Yeah,
other.
but although the picture might show three plates, what you require are only two plates, but preferably kept at a height.
Hmm.
Yeah. So it need to
Okay?
be kept on a chair or
Otherwise,
anything.
it would be a complicated structure to analyze and explain and
Yeah.
understand.
So in any experiment, we will avoid to like keep those devices on floor or on the ground. So we'll keep at some height, like using chair or anything. So avoid metals, like whenever using like to keep some distance from the ground. So avoid metals, I would suggest. So yeah, so you can measure the distance and see the power, how it is varying at, you can also change the angle. So from this end to this end, slowly you can go from like this side to this side in arc. So you also see the variation in the power. So at the receiving end. So yeah, so these are the manuals, you can go through it. So in a while, and the installation process will be explained by Ashish. And there are other two experiments, so which is going to be conducted and handled by Prakash and Ruta Subhashish. So
Hello,
anything you
sir.
want to add? Yes.
Sir, can you explain the sea surface interferometer experiment, sir?
Sea surface, the fourth experiment, so which is the
Yes,
reflecting
yes, sir.
interferometer. Yeah, Ashish,
Yes.
I'll stop my screen share so you can share the
Uh,
screen, Ashish.
yeah. So as you can see here, uh, what we are doing in this experiment is trying to see an interference pattern. Desh can probably elaborate on the historical significance of this experiment. and how it was used in radio astronomy. But the setup is as shown in the diagram. You have a receiver and a transmitter. So receiver is, let's assume that this is your laptop, and the transmitter is your mobile phone, and
Uh,
you have kept the laptop at some height, typically 1 to 2 times the lambda that you are operating at, and you have this transmitter, and you move this transmitter vertically.
I
So
think I think you got the transmitter and receiver exchange. That might confuse people. Okay,
okay,
so
okay. Uh, yeah, so you can move the device, the mobile phone vertically, and what
mm,
this will do is you can place a reflecting surface here, so something like an aluminum foil, and what will happen is that there will be one direct path, and there will be a reflected path, and when these two signals superimpose, they will create an interference pattern depending on the lengths of these paths. So you can actually derive what will be the path lengths for given height and distance, and the height at which your laptop is kept. And I have that derivation. I will discuss once with Desh, and then we can circulate the derivation. Uh, yeah, but once you know these part differences, you can actually determine at what points you get maximas and minimas, and you can verify that with your observations. So that is the basic idea of the experiment. So during all these experiments, one thing that is required, so there is a README file in the folders for softwares, and you can go through that file to understand which what thing to use for which operating system. And one thing that is recommended in all these experiments is that you do not connect to the internet while doing these experiments, because if you connect to the internet, we see that the fluctuation in your noise, or let's say
power.
in your measurements power is very high, and so that is the reason why you keep your mobile phone on flight mode or airplane mode, in as it is named in some of the devices, and you just create a hotspot on the mobile phone and connect your laptop to that hotspot, and run the data acquisition software on your laptop, and use your mobile phone to do any moving around. So this goes for all the experiments, and it is also mentioned in the software write-ups. So for Linux, there is a Python script which Prakash has put in the folder, and yeah, you can go through his documentation. He has given the procedure how to use the Python script. For Windows, there is software. I can show you actually. Yes. Yeah, so for Windows, this is the software that we use called WizTumbler. It is a very small package, uh, 5 to 6 MBs, and it's pretty straightforward to use. So in most of these applications, what you see is that once you start the software, you will see that there are a lot of channels. If depending on number of Wi-Fi access points are there around you, you will see several of these access points listed in the software. But you are interested only in your mobile phone or the device that you have created the hotspot on, and so that is why you have to create a filter to ignore all the other access points and just to capture data from your mobile phone. So how to apply that filter is given in the documents. It is again pretty straightforward. So if you have any difficulty in using this filter, applying the filter and collecting data, you can contact us. So this is for Windows. Similarly, for Mac OS, there is Wireshark with similar features. It is much more versatile, but it supports only a limited number of hardware adapters, your Wi-Fi adapters. So it might not work on all systems, but we have checked it on Mac and it works. So I have also given in the README file the list of adapters which are supported by Wireshark. So if you're lucky and if you have that adapter, you can use Wireshark. Wireshark actually works on all three operating systems: Linux, Windows, and Mac OS. So just check the compatibility of your Wi-Fi adapter with Wireshark, and you can then use this to collect data and plot your graphs. And there is a Python script for using getting signals on Linux systems. So I hope that clears it. There is a README file here which gives the details of how to use, what to use, and the installation procedure is very straightforward, and usage is given in individual manuals. For Android, if in case you don't have a laptop to record the signal and you are stuck with using two mobile phones, then it is recommended to use Wi-Fi analyzer. Although there are several other apps which can be used, but this is the one which gives all the information regarding the signal that you're recording. Also, one important thing to note down that all these apps give you the power and the frequency of operation. So there are two Wi-Fi bands. One is the 2.4 gigahertz band. Other is the 5 gigahertz band. So just check your information of the access point as to what frequency you're connected to. So this is given in all three softwares, what is the frequency of the connection, and from that you can get the wavelength. So you will require lambda for doing calculations in your experiments. So similarly, this app also has the filter option, and you can filter out the plots, the unnecessary access points, and just look at the signal that you are interested in. And it also allows saving some short intervals of data. So this is one thing that can be used on Android phones. In case you don't have the laptops, don't are not operational as required. So this was regarding the software. You might it is recommended that you spend some time using these softwares so that you get familiar with how they work and how to use them properly. All the procedures are given in these documents, so go through them. And in case of any problem, you can contact us and we'll try to sort it out. So you can try this today itself so that you don't spend too much time on this thing tomorrow while the experiments are going on. Uh, yeah. Yes, so as Jamir has explained, there are four experiments that are listed, but these are I would say that these are guidelines. You can be more creative and try to find out things on your own, uh, and try to come up with explanations for the types of things that you see. And yeah, so that is all from my side. Uh, Desh, you want to say something about this, about the sea surface interferometer?
Uh, yeah, I think most of the experiments that we'll be trying to mimic or simulate using the setup that Ashish and Jamir just described are real approximations to the kind of experiments we would like to do. Uh, these, for example, the sea surface interferometer, although the name relates to the essential concept of where the sea surface was used to reflect rays that came parallel to the direct rays in the reality. Here you will find that the reflected path, is associated with rays emanating at another angle than the direct path. So that will be the major difference. And of course, you will have to understand and analyze that in terms of the extra path traveled, including the phase difference that will come because of the reflection in this particular case with respect to the direct path. And that will decide how constructively or destructively the two signals will interfere, and that situation will of course change as a function of height here. So most of the things that we had, I think the reason why Ashish labeled the transmitter to be moving is that that's how the source
Right. Yeah.
varied direction as seen from the observer. However, the pattern, interference pattern, will be seen at the receiver. So that's what I was referring to. So we will explain these, and of course you can do it in a variety of ways. The essential aspect here is like a distant source, we will not have the rays arriving parallel, part of it getting reflected by the sea surface and some coming directly to the receiver. So you will have to note that explicitly, and the expressions and the dependence on the height of either the receiver or transmitter, which we might change to see the changing interference situation, constructive or destructive, will have to be analyzed and understood in that fashion. Other than that, I have nothing else to add. It's always nicer to keep not have additional complication by reflection from, as you can see that we are actually using the reflecting surface as a part of the experiment, which underlines the role any reflection from the ground can play. And so in order to avoid prominent role of that, those kind of reflections in your experiments, which are meant for studying something else, it is recommended that you keep both your transmitter and receiver at certain height, so that there is no prominent reflection and the direct path power dominates. That is relevant for the general 1 by r square dependence of the power received, then also for the corner reflector and the back reflector investigations, or any beam pattern measurements that you would be doing. All right, thanks.
So Pranav has asked what software package to use for data analysis. I think you can use whatever you are comfortable with. There are no restrictions on that.
It will be better if you know your hardware well. So whether it's a cell phone or any like Wi-Fi hotspot, and if you're using a cell phone, it also better to know where your antenna is situated in your cell phone. So you can Google it or you can search online. So based on your device and model, so like where is the antenna? So that in some of the experiment you can keep your devices exactly at the right place and right position. So that is one suggestion from our side.
That is an important point. All the distances that you see here are with respect to the antennas in the devices. So if you can figure out where the location of Wi-Fi antenna is in your device, that will improve your measurements greatly.
So it will avoid the error and the mistakes.
Yeah. So someone has asked, is metal necessary? So in this experiment, you will get better results with a metal surface. If you don't have an aluminum foil, you can place some metal plates on the ground. But you can also see the difference if you place a metal plate and not place a metal plate, and try to see if there is any difference that way. In other experiments, metal surfaces will be necessary.
Yeah, and in general, the smoothness of all the reflecting surfaces and so on need to be only to the level of wavelength divided by 20 or finer. So it need not be very fine, even if it's a little coarse, but below lambda by 20 kind of limit, then it's good enough. And the wavelengths, of course, will be based on, somebody was asking about the wavelength. Yes, you, in this particular setup, you will know the wavelength from the, whether you're using the 2.4 gigahertz transmitter or 5 gigahertz. All right, so you can.
Yeah, and one more suggestion is that before you start doing the experiments, it is good to just see the statistic uh, of the data by just placing the transmitter at and the receiver at a fixed distance, and just record some data to see uh, how much of variance that you get in your data, and then start doing the experiment. Uh, so that will give you some measure of uncertainty in your measurements.
Also, most of these numbers will be in the log units, dBm typically, uh, which are basically a ratio of the power to 1 milliwatt, and log of this ratio to the base 10 times 10. So you might want to convert that back into a linear scale for understanding certain aspects more clearly. So have that in mind.
So in few experiments, while recording the data, so you may need to wait for a few seconds or few minutes actually, because it may take some time to get stable. Even if you're moving, if someone is moving around you, so that may cause some like instability in the reading. So that we need to take care. So there are some precautions we need to take care. So while doing this experiment.
Yes, so that is again an important point. So whenever you are trying to measure, when you are in the measurement mode, try not to keep any disturbances by moving around the setup, or by moving your hand or all those things. So these devices are actually very sensitive. Their noise floors can go to minus 90 dBm. Uh, so any small movement might change your measurements. So try to avoid those kinds of things. Uh, yeah, but it should not affect very much, but it will give you better results.
Ashish, somebody's asking, I have a network
Yeah.
beside my home. Will that create any problem?
So I guess you are connected to only your cell phone and you're filtering it. So I guess it should not
Yes.
affect that.
So as I showed here in this Tumblr document, Yeah, so if you have more than one connections around you, all of them will be listed here, and you have to filter out just the one that you are interested in, that is your mobile hotspot. And the procedure to do that is given in the documents. Yeah, so you can filter out all those other unnecessary channels and just look at the data from the mobile phone.
Yeah, Ahmed is asking how to know the wavelength. So basically, this Wi-Fi they operate at two wavelengths, so either at 2.4 or 5 gigahertz. So you can check using your devices like laptop and cell phones at what wavelength they are operating. So when you click it on 2.4, so it should show some data or the power. If it is not connected and if it is not operating at 2.4, then it should show at 5 gigahertz.
Generally, the high speed version will be high speed mode will be at 5 gigahertz.
5 gigahertz.
The normal speed mode will be at 2.4 gigahertz.
Yeah, so for example, in this Wi-Fi analyzer app, the here you can see the frequency of at which I am connected. It might be, yeah, here. So once you start plotting, you will see what frequency you are connected to. There are other informations relevant to Wi-Fi communication, but that may not be necessary for the experiment. And this is shown in all the apps that you see.
In fact, a simple back reflector, the reflector at the back of the transmitter, which ideally should be at lambda by 4 distance for better reflection, can be used for you to even find out the wavelength.
That is true, yeah.
Initially, you might want to try that out and convince yourself that indeed you're looking at that wavelength.
So you can actually move this reflector and see at what points you get maximas and minimas, and that should give you the wavelength at which you are operating. So in case you can't figure out the wavelength, this is a very good method of estimating the wavelength. Yeah, and also keep your mobile phones and laptops charged uh, for the duration of the experiment. At least they should last for the duration of the experiment. Prakash, you want to elaborate on the Python script for Linux?
Hi. Okay. So let me see. Can you just open? Yeah, the document. So just to get an idea, how many people are using Linux? Can you guys raise your hand just so I can get a rough idea?
Yes, sir. I am using Linux Ubuntu.
Okay. I mean, you guys can just raise your hand so I can just look at the icon and know what fraction. Okay, I see about 4 of them. Are the rest of you using Windows or Mac, I assume? How many people are using Windows? Okay, a lot more of you are using Windows. All right. Anyway, I mean, if you're seriously interested in, you know, science related work, it would be a good time to try out Linux as part of the winter school as well, if you feel like it, or you can always do that at a later time. But people who are interested in doing these experiments in Linux, it's fairly straightforward. You don't have to install any particular program. What you have to do is simply know where the wireless signal is stored in Linux. And then I have written a Python, a very short Python script, which will essentially read it in real time. And it'll have these parameters as to how often do you want to read it and for how long you want to read it. And it will show you a real-time plot and then also save it as a data frame, if you're familiar with Python. Just out of curiosity, can you also raise your hand and say how many of you are going to be working with Python or have some experience with Python? Okay, that's a fair fraction. I would assume others also have some experience with programming. And if you have just about experience with just about any programming language, Python is not very hard to master. There's plenty of resources online. Whatever you want to do, you just Google it and you can, you have this Python notebooks, which can be run on Google Cloud itself, which I'll show you in a bit. And in principle, you can test it over there, the commands in real time, and then it's pretty straightforward, and we'll be there to help you if you need any help. So the basics of uh, using it in Linux is uh, there is a file. The location is given in the first line /proc/net/wireless. And if you read this file, it will give you the information about your Wi-Fi signal strength. And that is all we need to do these experiments eventually. I mean, once you take care of the physical setup, all you have to do is take these measurements according to the intervals and period that are prescribed, or according to what you think you want to try out. And then the rest of it is analysis or working with the data on Python. So the Python script essentially will read this and then plot it. Ashish, can you show the Python script quickly? You might have to open it in Collab if possible. Click on open with and say Collab.
I don't have that installed. Maybe you
Oh,
can share
okay.
your screen.
Let me see if my signal strength is a bit unstable. That's why I'm worried about trying it here. Do you have a way to view this?
Okay.
No, not okay. Yeah, sure. Yeah, that is it. So the thing is, although you can run it on Colab, which is this hosted server that Google provides for you to run Python notebooks like this on the browser itself, so that you don't have to install anything. But the fact that you're reading information from your computer means that you cannot run it on a hosted runtime, which is you cannot run it on a Google server. But the Collab app will allow you to use a local runtime. The I mean, what we can do is, if you do not have experience with it, in one of these afternoon sessions when we are troubleshooting and trying to uh, uh, s- personalize, personally see which how to run all these apps, I can help you individually over this. The idea is you'll have to install the softwares that are listed in cell 1. Can you scroll up? Yeah, the cell 1, it gives the dependencies that are needed. Most of them are pretty standard, except for maybe the plotting progress plot and Seaborn. These are somewhat specialized. I have written the codes in the subsequent cells, which essentially read the file, and then it has these functions where it allows for the flexibility of choosing the sampling time and the length of the observation. So that is what is done in, I think it's cell 5, where you use this 5 time series and you specify the time step and the number of steps you want to take. And once you run that in the next cell, can you scroll down further, Ashish? Yeah. So where it says this sampled f equals Wi-Fi time series, it will generate a real-time plot. So as you move your laptop, you can see that the signal will change. Once that is done, it will automatically store it in a data frame, which can later be plotted. This is a sample plot at the end that I've shown, which is obviously not real time, but once the readings have been taken. After that, I mean, it's up to you what you want to, how you want to manipulate the data and what you want to get out of it, depending on the experiment you want to do. But running this on Collab, or the simplest would be to download it and run it like how Ashish opened it in a Jupyter Notebook runtime, and then it shouldn't cause any problem. For Linux, I should also mention that it should be Ubuntu preferably. The location of the file might be different if you're using any other flavor of Linux. But yeah, the best is you guys should just try it out, follow the instructions that are given in the document, download this or run it on a collab app. And then if you have any problems, what we'll do is we'll also create a document where you can enter the problems that you're facing, so that even if we are not having a one-on-one session or such Zoom sessions, we'll still be able to answer the uh, questions that you pose over there. Any questions so far about this? Okay, if there aren't any, then I think we can move on. You can all lower your hands unless you have any question you want to ask.
Hi, excuse me.
Yeah, go on.
So about the group work, how are we supposed to do? We are supposed to do these experiments in group or individually?
Oh, so eventually you will be, I mean, it's best if you do it by yourself. Of course, your setups will
Yes.
all be different. The groups are assigned so that you can collaborate on solving each other's problems or discussing how to go about the experiments in general.
All right.
Yeah. So all of you must have got the groups that that we had made yesterday night, right? The link to it. So just get in touch with your group members and then open some channel of communication for your group alone. And then if you have any doubts about the experiments, you can first ask in the group and discuss it, or as a whole, have a meeting where you discuss how you're going to go about solving these problems. You can take up one at a time. You can divide this among yourselves if you want, and then uh, as you get proficient in one particular experiment, you can explain it to others and bring them up to speed. It's up to you. We are sort of letting it somewhat open and letting you decide how you want to do it. But of course, we want all of you to eventually do this experiment, at least one in your home with your setup.
Okay, thank you.
Sure.
So there is another question. So if we take data from the software and can't analysis them on a Python, so yeah, you can analysis, you can record in some format like say CSV format, and then you can either analysis on a Python, MATLAB, or any software you are familiar with, or any tool. And the second question is, will we do signal processing or image processing from the data? So I guess it may not be image processing or signal processing, of course, but may not be image processing, as far as I know.
I think he's clarified the question. I think it's relating to the other projects or
Yeah,
other experiments.
the
Okay,
two other
will we be
experiments.
doing
So the
things?
data.
Yes, the answer is yes to that.
Yeah,
So
definitely we're doing signal
image
processing.
processing will be done, right? Or only signal processing?
Yeah, it will be image processing is possible, but not included presently as an explicit thing. Okay.
Okay.
Because that might involve access to variety of tools and so on, which you may or may not succeed in. Not everybody might have those platforms and tools accessible. But yes, it will be largely signal processing.
So if we have a doubt, could like if
There
we
might be
try,
some aspect of images and so on.
yeah, but if we
One
try,
of the
could someone address the doubts if possible?
yes, we will be in discussion largely during all those sessions, as well as there will be a special session in the evenings when people can actually raise related doubts.
Okay, thank you so much.
Ruta and Shubhashish here.
I guess they are not here.
Do you all
Do we-
have any other questions about these experiments?
Actually, I wanted to ask about sea surface experiment. If like as per the diagram which I can see there, it seems to be a two-ray model. So in closed system, won't reflection due to wall affect it? Like it won't it change the number of rays coming to
Yes,
the
yes,
receiver?
certainly they will. Certainly it will be a mess in general in a closed room and with other furniture around and so on, which might have other reflections. And so to be able to keep the system simple, it's always advisable to go to, sort of open area if you can find. If you cannot find, of course, be mindful of the possibility that other reflections might contaminate your measurements.
So in
You're
that case,
absolutely right. Yeah.
can we use theoretical equations related to 10-ray model or somewhat
No,
similar?
yeah, you can, but there is no limit to it. Okay. It's not, so it's not exactly one ray or two ray or n ray model. It's, the entire Fourier optics. Okay. It's not ray optics anymore. It's okay for illustration. So what we have is, interference from every piece of it, and, collectively showing the resulting pattern that you would find. In fact, if you people have time and energy later, you can actually map using your mobile phone uh, the environment in your room, and you would find that there are good spots and bad spots within your room, and that can be inverted. That information can be inverted to find out where the major reflections are coming from.
Okay, thanks.
So it will be always better if you conduct these experiments in a slightly open area, so that you can get the less reflection from either wall or any other instrument, furniture, or anything.
Or at least keep your setup in such a location location in the room that other objects are not nearby, like central region of the room. Other walls are not, should not be close to this setup.
You will have finite reflections from other undesired surfaces. That is unavoidable, but we will try to keep them small, right?
It might be interesting for them to also try it out by putting it in open sort of space if possible and in closed space and look at the difference actually. No?
Yes, absolutely. No, that's the part of experimentation you should do to assess how bad it becomes or how good it becomes when you're in the open space. Yes, it's important to assess that role. In fact, as a corollary, many of the times that you receive, or almost all the times that you receive your mobile phone signal in a room, while there are concrete walls and so on, there might be just a door open, is thanks to all the scattering and reflections that are occurring, through which you actually get this signal at all in the place where you're sitting. So it's, while there are these good sides of it, you will also find that there are regions where interference from all these reflections, and with not just reflections, there will be absorptions, there will be partial reflections and so on. So some total of it will decide where the signal is high and where the signal is low. And mapping of those itself is an interesting exercise, as well as comparing these environments, as Saikya said. How much difference does it make in the open space versus a region that is surrounded by other unavoidable things?
Will we need constants like ground reflection coefficient for theoretical proof of it?
Can you repeat that last term, special term that you use?
The ground reflection coefficient, the one which is
No,
present
so
in the formulas.
Yeah, you can even estimate it, okay? Because you will find that the amount of variation, the ups and downs that you get, are not deep enough, right? That means when you get to low intensity, it doesn't become very low, right? It still is well above the real null. And so that will tell you that, both the things that are interfering are not of comparable intensity, okay? If they were, they have a chance to cancel the contributions, correct?
Thank you.
So the depth of modulation, or the amount of the depth of the fringing will actually tell you the relative comparison of these two contributors. And from which you can estimate the reflection coefficients and so on if you analyze that situation properly.
Thanks.
Yeah, Sahil is asking one question: where shall we share our result for clarification? So we have similar sessions, so we can discuss your results and your problems like during our experiments and discussion sessions.
Yeah, and yeah, as Desh has just discussed, so the write-ups are just guidelines. You can be more creative and try to do things on your own, and find out more about the setup.
Yeah, in fact, the write-ups will best not given to you. Just the basic idea will be given to you, okay? And with these devices, you can perform the experiment. So it's not, then it will not amount to just taking readings and plotting them, but actually, even arranging how to do that will be left to you once the essential principle has been mentioned.
So we'll do the experiments in tomorrow's like we have a experiment session tomorrow. So we'll conduct 2 experiments and in first session and 2 more experiments on second session. So by that, if you want to try, you can try. Otherwise, we'll do online here, and you can do from your side at your home. And if you have any difficulty, we can discuss during that sessions. So all the writes up are shared with you guys, and now you're free to start experimenting it or start setuping it. And we'll also do experiment tomorrow. And then if you have anything, so then we'll discuss in that period. So you want to add something, Ashish and Desh?
Yeah, I think I just wanted to add that there will be other analysis aspects that will be relating to GMRT data and data from OT telescope, and they will be also discussed in subsequent meetings.
Hello, sir.
Yes, go ahead.
Is it okay if we means first start with a theoretical model of this experiments, and we can clarify it with the experimental model, and we can compare it both of them, and we can share the results with you.
Yeah, there is no particular sequence in which one needs to do this. You will find as you think, your brain is not going to make a difference of theoretical model and the way you will actually see the thing. So you will be relating that to something that you can model and make a prediction or assess how things should change. The expectation will come from some kind of modeling, right? And
Yes,
so
sir.
you will be making the comparison with what is expected and what you observe.
Yes, sir.
So
Yes, sir.
in the way you will go about assessing what is expected, all these words will be relevant: modeling and theoretical and so on. Okay.
Yeah, okay. Thank you, sir. Thanks.
I think if any other questions, if not, we can probably stop today or what?
Yeah, looks like Sakia, as the evening session information has
Not been conveyed. I mentioned it briefly in my talk, but
okay.
yeah, Desh has suggested, and we have sort of we'll make it facilitated that there can be evening sessions with the teams to actually discuss your challenges, difficulties, clarifications, anything actually, very informal. This is not part of the regular schedule, but depending on your need and the issues that arise, we can schedule it. I mean, Ashish may be busy during the day. That's one of the reasons we're putting it in the evening. And so that is, if there's any thoughts on what time would be most convenient or what would work for you all, then let us know. And we will start scheduling that as well. Dish, you want to add anything further to that?
No, I think I think if one knows what time would work or is going to be assigned to this, then people, depending on their availability and so on, can join that session. So that will be an informal thing where one just happens to run into each other and ask questions and discuss.
I'm sure once you start doing things, many questions will arise, and the idea is that these evening sessions will help address some of those.
Yeah, so once one sort of gets an idea of what time it's going to be, then that might set the tone.
Will it be possible to form a Slack group for conveying the messages? That will be a bit easy.
Sorry, form a what group?
Pranav, can you repeat what you said? You were referring to some group, right?
I guess he's talking about Slack.
Yeah, you people within your group can choose to communicate in any fashion, right? That you find convenient. So yeah, Slack is one of the one another way of formally sharing documents and having a discussion and so on. So that's left to you, all of you, to choose within your group. You can together also maintain any Slack version where others are, also looking at it and benefiting. It's there is nothing specified that we would like to specify for your discussion among yourselves.
So perhaps for the orientation, we can stop now, right? And we will meet tomorrow morning at 10. And somebody has asked, how will we be informed about the timing of the evening sessions?